Hi everyone, I'm Kripa. I'm a technical program manager at Google. I've been there about 8.5, 9 years. And I work on several infrastructure projects. I guess a lot of things to do with security, privacy, user data at Google. And by chance, I happened to get into disaster recovery at Google very, very early on. So the last 8 years, I've been leading their disaster recovery program, also known as DIRT. I was brought here to talk about our disaster recovery program, but I wanted to emphasize a couple of points as we go along. So as part of this presentation, I'm hoping I can share some stories that we've done with some examples as part of our testing exercises, and try to emphasize some points and some things that you might be able to take home with you and apply as appropriate to your organizations. So basically, DIRT stands for Disaster Recovery Testing. This is our annual Big Bang disaster recovery exercise. It's been going on for about 8 years, I think, I don't remember, but roughly about 8 years. And basically, this is the exercise that we do once a year. It's a multi-day thing that happens that to simulate a lot of failures or inject failures into our systems, our processes, and everything that we do, so that we can test to make sure that Google is actually resilient in the event there is some sort of major disaster. Now, a major disaster could mean lots of things to lots of people. It could be a natural, disaster. It would be a massive earthquake. A data center that goes offline. It could be some data deletion bug that causes a widespread chaos. It could be anything. Different things mean different things to different organizations. But to us, we were just talking about a natural disaster, roughly speaking. But it applies to a lot of other things. You'll see that in a second. The basic premise is that if we were to suffer something like this, we're making the assumption, it's very hard to predict, but that we will not have 30 days worth of our headquarters. Headquarters are incapacitated for about 30 days. The scenario changes lightly, but to keep things simple for this conversation, I think we'll just focus on Mountain View because that's our headquarters and we have a 30-day outage over there. Of course, we totally take down other offices and other facilities, other data centers, create network fiber cuts, whatever we want. Each year, the themes are different and the kinds of things we do are different. But we generally, this sort of stays somewhat reasonably constant as an assumption that we work with. It generally happens annually. I cannot tell you when. But it goes on for about 3 to 5 days, or sometimes longer, sometimes shorter, but generally multi-day exercise. We're working round the clock to make sure that we're not just testing the stuff that we have in place, but we're stress testing the teams that are working on it as well, and the management and the incident response. There's a bunch of things we'll cover in a second. But this is the Big Bang thing happens once a year, but we have a lot of continuous testing that goes on throughout the year as well, which I would love to promote. I mean, I am promoting it, but it makes my job really hard because finding things to break becomes tougher and tougher every year. And who's actually involved for the big exercise, a thing that we call DIRT? Literally hundreds of engineers across several of our operations groups, our SWE groups, security facilities, all our business teams, the HR, finance. Essentially, it's a Google-wide exercise, and pretty much major business units are often part of this. So this is kind of what we call DIRT. It may be worthwhile to talk a little bit about the structure over here. So basically, we roll this exercise out, and it starts at people kind of know it's coming around this month, but roughly maybe this week. But nobody knows exactly when it starts or how we're going to roll it out. We roll it out by whatever, I don't know, a radio announcement or some sort of blog post or news article, or we decide how it is, or we actually cause an outage, whatever the right thing is. We start it off, but since we're talking natural disaster over here, the first 24 hours of this testing is really about our crisis response and our ability to run our operations from different sites in case you lost the primary site. Then you continue the rest of DIRT. There's a whole series of injected failures, because if you're talking about 30 days compressed into 5-6 days, you're talking about a lot of failures. 30 days is a long time for things to happen. So we compress a lot of these things, and it sort of has the secondary effect of stress testing teams that are actually working single-handedly from a single site. So it's kind of becomes pretty intense during the course of it. And the team's the inside team is really not that large. The main coordinating team is like about 5 or 6 people, really. For a company-wide exercise, I think that's pretty cool. But we do have makeshift teams of 30, 40 people that come together once a year. And this is the team that the insiders, they're the team that help with coordination, designing the actual disaster, designing each of the big simulations we do in the disaster. When I say simulation, this is a simulation in a live environment. It's simulated only to the extent that there's a team that can roll back whatever disaster we caused, just in case it was causing a real issue that should not be happening. But other than that, it is actually real. Everything that we do is in a live environment. We make sure that this actually happens. Then I think in the team, we have a person that's called a storyteller, who probably has the best job at Google. the job is to make up stories and actually is the newscaster, if you will, to sort of tell everybody what's going on in the media about the stuff that's going on as part of the disaster. And hundreds of teams are responding to the test. But this is not the most important part of any of this. This is all the drama that goes into it, right? The most important part is this. Once we're done, hundreds of teams actually write postmortems for every one of these tests. We're talking hundreds and hundreds of tests, right? Every single one of them comes with a postmortem. You find issues. Some tests are perfect. They don't learn anything. Some tests you learn lots of stuff. And then you spend the energy to fix it, because the fixing thing is actually what matters more than everything else. That's the takeaway from anything that we do with respect to disaster recovery. Since this is a short-ish presentation, I'm going to run into a handful of examples of the kinds of things we do and the learnings we've had from some of these things. There are some examples that are a bit old in nature because we've changed things, but I can't talk about the things we've changed. But they're very, very good learning exercises anyway, so we're going to go into some of them right now. So I'm going over 4 different parts of the same disaster, right? This is all happening in multi-days, so not all of this will just extend over a period of time. So it's the same disaster, but I'm talking about a handful of examples as part of it. To start this off, like I mentioned, the first part of it is all about crisis response and emergency response. And we actually have someone in our team that sits and researches what happens in the event of a disaster. So, I mean, we don't have to go that far, but I'm just saying really, this person spends a lot of time talking about if the epicenter of a TBD earthquake is at this point in the fault line, then this is the radius of impact, then potentially this type of structure will break, this other type of structure won't. I mean, it's kind of, I think they're totally happy. I mean, they love doing this stuff, and it's actually super awesome for us because we can design a realistic scenario based on it. But I was raised in the world of Disney, and Disney believes in everything is happy and there's no grunge. So we changed that around to tell a story. So our stories involve zombies and aliens and whatever else makes sense for that year. Portals, maybe, I don't know, we've done a bunch of things. But the storyline mimics what would happen in an actual earthquake, right? So we would make up scenarios, but the whole thing is based on what we believe would happen to the best of our knowledge. I mean, you can't predict what really happens in a disaster to our knowledge. Once we roll this out, we're expecting a few things in response. So the response could be, hey, can you pull all the people that are around to safety? Can you find the people that are actually in the building? Can you find the people who are traveling to that office? Do you know if they were in the office or in their hotel rooms? Do you know if you can alert everybody on campus, outside of campus? Can you tell them what the right communications are? You don't know what's actually available. And can you make sure that if your headquarters or whichever office is incapacitated, is there someone that can sort of take over for them in another office? Can the systems fail over somewhere else? Can everything just run magically from somewhere else that's not Mountain View? So that's sort of the whole incident management bit. And you need to talk, right? The whole thing is about communication, just all the time. And did we learn anything? Of course. Question would be, I mean, lots of buildings do evacuations. You do evacuations one building at a time. Usually it's at some pre-known time and date that people leave the building. With a massive evacuation, you're talking about a whole campus, that's a whole different story, right? It's a lot of people that are leaving buildings a lot of times. It's the same amount of parking space you have for everybody that's going to go and assemble somewhere. It's a pretty big deal. So we tried that out, and that we found a lot of errors in it. The next one is actually a great thing. So about 6 years ago, I think this was from Dirt 6-7 years ago, a bunch of our key people in one of our offices was given they were all given satellite phones. So in the event we lose communications, you're all supposed to contact everybody, just get to this correct, connect to whatever number, call physical security, whatever the right thing is, use your satellite phones. Now, does anybody know what the problem with this is? The problem with a satellite phone is in order to get a real signal, you climb to the top of the roof. In an earthquake zone, this is not a very smart idea. Also, if you don't use this all the time, your satellite phones are not charged. Nobody knows where they are. They people don't know the instructions to use it. Nobody actually was able to work with it. So in the time of a crisis, in our simulated crisis, they knew it was coming. We had 0 responses from a satellite phone to the number we wanted them to call, 0 responses. And that was pretty shocking, right? So we went and fixed that. We did something else about it. So that's not great for communications. A third example we have is the whole concept of the people alerter. So let's say you have this magical system that knows your pager number, your phone number, it knows your email alias, and it says, okay, if I want to notify everybody in the Bay Area there's an emergency, don't come to work next day, whatever the right message is. The message has to depend on the scenario. And you send it out through this magical system. The magical system does not know how to acknowledge all the the responses from each of these things. So I got a page, I got a text message, I got a phone call, I got an email, a second email from a group's alias. I was spammed. I mean, it's a single person. The entire company was getting spammed. We were clogging, our text messaging gateways. We were clogging all sorts of things, and everything stopped working. And people alerter not working as intended. So we had to fix that, right? That's sort of the If that's the thing that you're using for emergency communications, practice all the time. Anyway, so we recorded a bunch of these findings. This is the first 6 hours of the exercise. 6 hours is enough for us to do this. We went and fixed a bunch of things. Let's talk a little bit on the technical side. This becomes very interesting, which is, let's assume that first 6 hours, all the offices have failed over, everybody's running systems, everything is great. At this point, my little team on the side, the little command center, we end up trying to simulate actual technical disasters too. So we would do something like simulate a fiber cut, which means we did not go and actually cut the fiber, but we did whatever it takes to simulate that cut, which means systems actually go down. You do not have network connectivity to that data center, so that's something we did. And the response we're expecting is, magically all these systems will come back online, and nobody notices. That's what the ideal result will be. All the systems that are in that data center have failed over somewhere else magically. Like systems, I mean, that's what we expect, right? That's the expected response. And we learn all sorts of wonderful things by doing that. You can do this on a much smaller scale. You'll still learn the same things. We started very, very small. We started with figuring out that the first time we did this, we didn't know how to come back. The second time we did this, everything was smooth. We did not hear a peep. There was not a single page anywhere. And the problem was the monitoring system we used to alert if something went wrong is in the data center we took down, and it was not redundant. So that was not great to fix that. And then we realized that if we took, I mean, oh my God, there's so many stories. But anyway, we took down the Mountain View campus and a nearby data center at that point. This was like maybe 7 years ago again, I think. And what the engineers in Mountain View decided was, okay, nothing's working, so we have nothing to do, so let's go eat. And they all went to our cafes, and I think that was the biggest scolding I got from anybody at Google. The chef of that cafe was just completely, oh my God, that was not a good day. Other things that we found, if you have, let's say you have an approval system in your organization, something that you file a ticket or something, it has to get escalated to get an approval to buy a computer, or to get, I don't know, to pay a vendor, whatever you might have, something that goes up a chain that someone has to sign off on, and then you do something. Let's say that system is great and it works beautifully. It fails over to this other site. So someone files this ticket and it goes all the way up the escalation chain. What if there are no people that can actually approve this ticket on the other side, and there's no one who can change the administrative privileges that goes off? Suddenly you're creating all this paperwork around the place. Nobody knows what's going on. Nobody has any systems. So the point I'm trying to make there is specifically, we don't test people separate from systems. They come together. People are very dependent on technology. Technology depends on people. So you can't just do one and the other and say we're great. Like somewhere you have to try to mix the two. It makes a very, very big difference. Phones, oh, this is great. So I don't know how many of you come from organizations where the culture is, let's try to avoid the phone as much as possible. A lot of our engineers do this. We chat, we use email, we're even willing to write Post-its before we pick up the phone and call each other. Right? This is like, go all the way there. And so during a disaster, our primary thing was, hey, look, all of you are going to get on this phone bridge and talk to us. First, lots of them didn't realize they hadn't even configured their numbers. Second, they didn't know how to call an external line. Third, I mean, there were so many problems, it was ridiculous. And then, once they figured out how to get on the right bridge, which many people were on multiple bridges because the documentation was bad, but once they all got on the right bridge, this one doofus turns on, the whole hold button and goes away. And then there's wonderful music and nobody else can actually talk. So it's a failed bridge, and nobody knew the commands to boot these people off the bridge. There was a lot of issues over there. But it's a simple thing, like get on this bridge, is actually not functioning as intended unless you test it. It's a very, very simple test, right? And finally, we were worried about whether we can recover. How quickly can you actually recover? And we started with saying, the first time we did some of these big tests, we didn't recover. And that was actually shocking for us. Like, oh, we're Google, and we don't know how to recover. Shame on us, and blah, blah. It took us several trials and errors. So we might be a massive company, but we failed several times over before we got to the point where we actually feel like we know what we're doing really well, right? So it took a long, long time. So I'm just saying that recovery time was not good enough. So now that the folks have fixed this fiber cut, things have come back to normal, we're bored in the war room saying, let's do something else. And we go and say, hey, let's take the power off of this data center. So we go and turn the power off somewhere else. And it's a very different stuff. What we were testing for is different. It's not about failovers. It's not this technical test. What we wanted people to do is to figure out if they can seamlessly cut over to their backup generators. So even if you have a single rack, sometimes it's not the cleanest cut when you lose main power and actually try to go to a backup generator. So can you run from secondary generators? Can you also, actually, if you do run from backup generators, there are certain rules about how long you can run on that backup generator for. So the environmental protection agencies generally have some limit on how much exhaust you can put out there and stuff like that. So if you have a large-ish facility, you actually have some limits over there, which we did not realize till we started doing this test. That was not good. That was not a good day either. And then you have things like, there's another test we did. This is kind of fun, where all we wanted someone to do was we made up some arbitrary giant number. Let's assume it had some 6 zeros. And we said to this person, or this group, when they were trying to find emergency vendors that will bring us fuel on site so we can power the new generators, and we tried to tell them, hey, look, assume you need, this vendor is demanding X dollars from you right now, X followed by 6 zeros, maybe whatever number of zeros you want. I need for you to find a way to fund it. And you don't have your executives that would normally fund it because they're not accessible because of whatever the disaster was. And all I wanted them to do is find that one page that tells them how to do this. There's an actual process, and there's a one page, but they didn't know how to do that. And they found 900 creative ways. They went and actually talked to the vendor and made up a deal. And they did everything. They did everything right, but they didn't do the thing I wanted them to do. It was really frustrating. But the final thing they did was kind of amazing, because they went after some Googler, or a combination of Googlers in some other office, and said, how much money do you have? Can you put this on your personal credit cards? And that's what they came up with, right? Nobody followed the actual process, but they managed to get it done. So I failed that test, yes. So anyway, that was that. I think, so we learned a bunch of things that were wrong. We learned that you can have documentation that says wonderful things, but it doesn't matter. If nobody ever looks at it, you can have a stack of perfect procedures, but if you don't practice it, it's just that. It's a stack of perfect procedures that will never get used ever. So, keep practicing and that would work. So that's what we fixed then. So I've talked about a couple of technical things. I've talked about crisis response, but what about people? People have needs too, and we tried to stress test that during the previous, one of our previous exercises. So we pretend that my war room, they are like the awesomest insiders ever, they sit there and their whole job is to annoy everybody that could be working in HR or legal or whoever they can think of, right? Because I'm not telling them whom to ping, and complain nonstop about something or the other. Hey, Google pays for this and that. Shouldn't they be paying for my clothing because I'm stranded over here? The only flight out for me is from LA and they're charging me $10,000 because XYZ. I need to rent a car. There are no rental cars available. Can I borrow a car? I mean, they're just throwing random things out there. And HR is required to come up with a policy that would actually work on this. And so, the thing was that they were very creative. It's actually, we're exaggerating the circumstance, yes, but I'm saying that what would happen is that what did happen, like Sandy was a great example for us, what did happen was the number of kinds of questions that were fielded by various people realizing certain places in New York had power, so they would organize themselves into lists of people who can share certain resources, and it was beautifully organized. And so that was kind of the thing that we were trying to do. But the other thing we learned from this thing, this is the last bullet point, when you're running this sort of exercise for multiple days is kind of what we're expecting to happen in an extreme circumstance. People get tired. And if you, in the first couple of days, you can deal with heroics, like random people can show up and they're all, I am on adrenaline, I can work for 48 hours. Forget 48, 24 is great. At the end of 24 hours, with a sleep-deprived person at the helm of this incident management group that we have, ask them to make a decision, and they make the worst decisions. They make decisions that optimize for themselves because they need sleep, they want to take shortcuts, they don't want to do stuff anymore because they're not handing off the reins to someone else. And so it's just a very, very interesting sight to see that we're not just playing around this. The 3-day thing, 4-day, 5-day, multi-day thing generally brings about a whole bunch of exhaustion. So we record and fix it. So I know this sounds like a very large deal. It happened over a period of time. So it didn't just first exercise was not like this. It was very, very small. I had to take down a tiny little source code system, and I had to get 900 approvals. Other tech leads were really mad at me, and they're all, who the hell are you? How dare you bring this down? That sort of thing. So we started really tiny, but it kind of grew into what we have today. So basically, I'm trying to emphasize a few points over here. The first thing is, it's okay to make mistakes. At least that's what the organizational culture should be about. It is okay to make some mistakes. And we definitely have done this over and over again. I don't know how many mistakes we've made, but the important thing is that you learn from them, fix them, and put them into practice again. We call this the postmortem culture. For every real outage, not just dirt, any real outage, anything that goes wrong, it doesn't matter if it's in tech or in the business units, it does not matter. If you make a mistake, learn from it, right? So just write a simplistic doc that says, here are the 5 things that we learned from it, go and put them into practice. The second thing is, This is a Big Bang thing, and the reason we do a Big Bang thing is for several reasons. A forcing function for people to come and test together. And the Big Bang thing also highlights issues and integration points between the organization. So if something were to happen, can tech and PR talk to each other, or can different groups in tech actually talk to each other? There are lots of integration issues of what surface the most, but we need to do some version of this all the time. And for continuous simulations and testing, engineering groups, long before the time we had Dirt, had a practice that I guess the more popular one was called Wheel of Misfortune. And what they would have is the teams would come together, there'd be a team person that has an on-call thing, and the person, had resolved an on-call issue. So they got paged for something bad, they got this issue, and the lead would sit there and try to explain to the others what the situation was, and everybody else is supposed to debug it on the fly, and they'll keep throwing wrenches in the works. It's a completely theoretical exercise, and they did this 1 hour every week, and it still happens today. And this goes so far, because the smaller the fixes you make, the harder it is for the larger failures to occur. So the small things matter. So ignore all this dirt. The dirt's just great for stories, but the small things really, really do matter, and I cannot emphasize continuous testing all the time for organizations. This one I alluded to a few times, which is test everything. There is no distinction between what we call disaster recovery or business continuity. Systems need people, people need systems. There's a huge interdependency, especially in the current generation, so just making sure that everything coexists and we test everything. And the final thing is repetition is important. If you don't use something, if you create a process just for this special circumstance that never happens, nobody learns. So it's something that you have to do all the time. So rinse and repeat. That was basically it. And that's all I had.